Let's do just one more example. Suppose a linear system has 5 equations and 7 unknowns. How many solutions could the system have? So generally, a linear system of equations, we know it could have one solution, could have infinitely many solutions, it could have no solution. Okay? But we have a little bit more information here. We know we have 5 equations. We know that these equations have 7 unknowns, 7 variables. So if we were to think about the coefficient matrix of this system, then we would have, so 5 equations. The number of equations would be the number of rows for the system. So we'd have 1, 2, 3, 4, 5 rows to this matrix, and 7 unknowns, so 7 variables. The number of unknowns, the number of variables to a linear system, that corresponds to the number of columns of the matrix. So I could have 1, 2, 3, 4, 5, 6, 7 columns to the matrix, and then the augmented part. Okay? So let's think about each case individually. First, is it possible to have no solution? So for no solution, we would need a row of zeros and then something not zero at the end here. We have a row. It's possible that if we get this into row echelon form or reduced row echelon form, that we get a row that looks like this. And so, yeah, it's possible that this kind of a linear system would have no solutions. So no solutions is possible. Obviously, it doesn't mean for sure we have no solution, but it means it's possible. Okay. What about one solution? So in order to have one solution, a unique solution, we need the number of columns to be equal to the rank of the matrix. We would need to have a leading term in every column. But if we actually think about this, I could maybe have a leading term here, and I could have a leading term here, and I could have a leading entry here, and a leading entry here, and a leading entry here. But then I've run out, right? The maximum rank this matrix can have is 5 because I have only 5 rows. And the rank is the number of non-zero rows in the matrix. So the most non-zero rows I could possibly have is 5. The most number of leading entries I could have is 5. But I have 7 columns. And so I cannot have the rank of the matrix equal the number of columns. It's just not possible. So having only one solution to the system is not possible. No matter what the system of equations is, if I have 5 equations and I have 7 variables, it's not possible to have one unique solution. I could have no solutions, or like in this case, I might have every row have a leading entry. I might have rank equal to 5, but I'd still have 2 more columns that do not have a leading entry in them. I have more columns than I have than the rank of the matrix could possibly be, which means I'm going to guarantee to have some free variables if this is a consistent system. Okay? So if this is consistent, it must be that I have infinitely many solutions. Because n equals to r, impossible. The biggest r could possibly be, the biggest the rank could possibly be is 5. But n greater than r is possible. In most situations, I mean, in every situation, this will happen. I guaranteed will have more columns than I have the rank.